Have you ever wondered how Bitcoin can run without a bank? Or how thousands of strangers can share exactly the same record of transactions? Hi, I'm Mr. Smarty Ben, and in this video, we'll quickly look under the bonnet and see how blockchain actually works. A blockchain is a special kind of database called a distributed ledger. Instead of sitting on one company's server, identical copies are stored on many computers around the world, called nodes. Every node runs the same software and follows the same rules, so no single organization controls it. Transactions such as Alice sends one coin to Ben are grouped into blocks. You can think of a block as a page in a digital logbook. When enough transactions have been collected, the network prepares this block to be added to the chain. Each block contains a list of transactions, a timestamp, and a special code called a hash of the previous block. A hash is like a digital fingerprint created by a cryptographic function. Change even one character in the data, and the fingerprint changes completely. Because every block stores the hash of the previous one, they link together in order, forming a chain of blocks, the blockchain. If someone tried to alter an old transaction, the hash of that block would change, which breaks the link to the next block and makes the later chain invalid. Other nodes can see that this version no longer matches their copy, so they reject it. That is why blockchains are described as tamper-evident. The network still needs a way to decide which new block becomes the official next block. This is done using a consensus mechanism, a rule set that lets honest nodes agree. Bitcoin uses Baintor's proof of work. Nodes known as miners compete to solve a very hard mathematical puzzle. Solving it takes a lot of computing power. The first miner to find a valid solution earns the right to add the next block and receives a reward in newly created coins plus transaction fees. Other nodes quickly check the solution. If it is valid, they add that block to their own copy of the chain. Many newer blockchains use proof of stake instead. Here, validators lock up some of their coins as a stake. The protocol randomly chooses one of them to create the next block. Honest behavior earns rewards. Dishonest behavior can cause them to lose part of their stake, so attacking the network is made financially painful. Users interact with the blockchain using cryptographic keys. Your public key or wallet address is like your bank account number. You share it so people can send you funds. Your private key is like a secret PIN. Your wallet software uses it to sign transactions. Other nodes can verify the signature using your public key and confirm that you authorized the payment without ever seeing your private key. Put all of this together and you get a ledger that is decentralized, transparent, and extremely hard to rewrite. Blocks of data, cryptographic links, and network-wide consensus, all working together so people can agree on a shared history without trusting a single central authority.